DevOps Iterations.
And here we are, 7 episodes of Abnormal DevOps Iterations, and we have it with Dylan Ratcliffe, which actually, Dylan, you have to know that I usually ask who I should invite to the people who attend to this podcast. And more than once you were mentioned. So it looks like, and actually you were already in my list. So I guess you are quite in the cool list, so to say.
Thank you, Alessandro. It is awesome to be
here. First of all, how are you? What are you doing in these days, Dylan?
I'm pretty well. I'm getting ready to go over to San Francisco this week or next week. These days, I'm the founder and CEO of Overmind. We are a pre-mortem product, so we go and work out what the blast radius and the risks of your changes are before you actually make them. And so I'm doing all kinds of, I do a little bit of engineering, I do a hell of a lot of product, I do some sales, I do sort of a little bit of everything these days.
I guess you have to do a lot of stuff as founder of the company. So how is it going? What are the things that you can do with Overmind? Let's talk a bit about the tool and the product.
Yeah, I was sort of inspired by, and I think that you'll probably be able to relate to this. I was inspired by, I was a Puppet consultant for a long time, as you are, Alessandro, and I was at a sort of company in London, and I made quite a substantial mistake where I took down their ability to save PDFs on their laptops, which is apparently something that the entire bank requires, and nobody could do any work. And I broke this on a Friday afternoon, and nobody could get any work done. And I sort of realized that even though they were using Puppet, they had observability tools, they had CI/CD, they had all of the technology that you would sort of expect, but none of it really helped in this situation, because the thing that we broke was something that nobody knew existed. It had sat in the back of a data center for 10 years, and nobody knew that we had this dependency. So I realized that all of the systems that we have now, all of the observability systems especially, really have the assumption that you understand your systems, which a lot of the time is true. But when they break, it's not true. When they break, they tend to break in a way that you didn't think was possible. And so you don't understand how that's happening. And so that sort of is what made me leave Puppet and go and start Overmind, is that I worked out a way to solve that. So there's a little bit of a long way of getting around to it, but I know that you've probably seen some of these situations before where you deploy something where you think is going to be fine, and then unexpectedly there's something that was built by somebody who's left, which depends on the setting being the old way, which suddenly breaks. So what we do is we discover the blast radius of your changes before they happen. And so we're talking Terraform changes here. We look at the Terraform plan, we work out what is going to be affected, what are all the dependencies of that thing, and the dependencies of those things, and the dependencies of those things, until we have the full blast radius. And then we use LLMs to do a risk analysis based on the actual changes that you are making. Like, is this change risky, and in what way, and therefore which elements of the blast radius do we need to check to see whether this is going to cause a problem?
Okay, which looks quite cool. Does it work well?
It does. So we always knew that we could do the blast radius thing. Part of the core stuff that we built, the first thing that I built, was an engine to traverse your infrastructure like a graph in real time. So we can start with like a security group, and then find everything that uses that security group, and find everything that uses that, and do that all in real time by hitting the AWS and Kubernetes APIs. We always knew that we could build that because it's not that complicated. It's sort of like, it works like a web crawler basically. But we knew that we could do that part of it, work out the blast radius. The part that we weren't sure about was, can we actually predict what will happen? We know what might be affected, but can we actually predict what might happen? And I didn't think it would work, to be honest. This was, we did like a test when LLMs were just starting to get very good. And we were testing a few different things. One of them was, can we identify whether or not a change is routine? And the answer was, at the time we couldn't. I think now we can, and we're going to start doing that. But at the time we couldn't. The other thing we tried was, can we predict what will go wrong? And the reality is, they're quite good at it. A lot of the time when something is going to break, it's because it's a weird needle in the haystack, sort of a discrepancy. Like, maybe you have made a change to a load balancer rule and you've made it most places, but you've forgotten somewhere that, like, you're changing a port. So you change the load balancer, you change the health check, you change most things, but there's one thing that you miss. And spotting those kind of discrepancies in a large body of text is, LLMs are exceptionally good at that. That's like what they are sort of built to do. And so actually it does a very good job at finding the sort of little discrepancies that humans often miss, and that often actually cause these big outages.
Cool. If I may ask, what LLMs are you using in the backend to work with this?
Currently, we use GPT-4.
GPT-4, and so it's actually effective in detecting the impacts. Can we go into details, if it's possible? How do you actually, what kind of information you provide? The diff, I guess, of the changes which you already, what are the integration, how, at what level is done, what is the...
So that is the most important question. What information do you provide? Because the difference between it producing a good answer and it producing an absolutely useless answer is, what information do you provide? So you're right that we provide the diff. So, you run Terraform plan, you get a plan of what it's going to do. That's basically the diff. We provide that, not in quite that exact format. We sort of optimize it, but we provide that set of changes that you're planning to make. But if that's all you provide, and you can do that yourself, you can run Terraform plan or whatever, there's plenty of tools have an equivalent, and paste that into ChatGPT and ask what the risks are, and you will get terrible quality risks. They'll be really generic and really not all that helpful. In order to make it high quality, you have to feed in, here are the changes that I'm going to make. Here is what the infrastructure looks like right now that I'm going to be applying the changes to. Here is everything that depends on that infrastructure and what the dependencies look like. And here is the overall structure of the cloud and everything that could reasonably be affected by it. And you really do have to be pretty opinionated about what that information is. And you have to do it in such a way that you don't blast through the context limit of the LLM, because of course you only get 120,000 tokens, which is sort of about 120,000 words nowadays, which in a large cloud environment is not a hell of a lot. There's if you change a security group that might affect 3,000 instances, you certainly can't describe all 3,000 instances. So being intelligent about what you give it is difficult. That's quite one of the hardest parts.
So actually, you started the company before the full, let's say, the madness about LLMs and everything. So did you have a sort of pivot, or you just somehow improved on the original works and idea?
To be honest, thinking about it now, it sort of feels a bit like a pivot, but it didn't at the time. It always felt like the obvious next stage. When I first started, you're right to say that this stuff didn't exist when I started the company, and it would not have been possible to do it when I started Overmind. But I was building the blast radius thing already. I knew that I could build that. I knew that I had a real-time graph traversal engine that could calculate that blast radius, and we were already going in that direction. And what we found was that showing that to people was basically unhelpful, in that on its own. If you took a change and said, here is everything that it might affect, and there was 200 things in that list, people are sort of like, that's going to make it take longer to review this pull request, not shorter. Like, that's not, I want to review less pull requests. I want to automate approvals for things that are low risk. I don't want to review 200 additional things. And so finding a way to summarize that in a way that was useful was the next thing that we had to do. And we got reasonably fortunate that at almost that exact time, LLMs got to the level where they could produce a set of risks. And then based on the risks, you then might look at the blast radius, because if it said, hey, there's a real risk here, you're going to want to go and validate that it's correct. And the blast radius gives you the information you need to do that. But without the risks, it's sort of too much information.
All right. Do you plan to do some kind of, let's say, more integrations and use more LLMs to improve the product and add new features or new capabilities?
Yeah, I mean, one of the things that is becoming the obvious next step is doing incident response. So because we are capturing the state of the changes, so we know what changes you made to what infrastructure, we know what the infrastructure looked like and what the risks were. We will soon be capturing what you did to mitigate those risks. And we also capture the before and after snapshot, so we can see what actually happened. Because we have that set of information, it's actually reasonably easy to go in reverse. So if we take a description of an outage, say like, I'm getting increased latency at this endpoint, we can use the fact that we can traverse the infrastructure as a graph and the fact that we know what all the changes were to work out what might have caused it. So there's a little bit of LLM stuff in here, but a lot of it is just taking the features we already have and doing them in reverse. So if you were to say, this URL is giving me 500 errors, we can hit the URL, we can find out what the DNS entry is, we can work out which load balancer uses that DNS entry, which, I don't know, Kubernetes or ECS or EC2 instances are targeted by that load balancer, and work out, all right, here is the set of infrastructure that could be causing this problem. Now that we have that set of infrastructure, let's do a reverse search and work out all the changes that have happened recently to that infrastructure. And then this is where the LLM comes in, read through all those changes and work out what is the most likely to have caused this, because the LLM can very quickly read through a bunch of like innocuous tag updates and say, no, that's definitely not relevant. Whereas a change to a load balancer rule is very likely to be relevant. So it'll bring that up straight away.
Yeah, that's interesting. And actually, this reminds me that infrastructures have evolved and made and have been more and more complex over the years for the numbers involved, for the kind of technologies behind, and so on. So some way to deal with these complexities definitely needed. What is your general opinion on where are we going in terms of IT infrastructures?
That's a good question. I'm seeing a little bit of a split. Sometimes you see people who are going all the way to serverless and lots of lambdas and things like that. And when I look at people who build applications that way, it looks like the application and the infrastructure are just going to merge together into one sort of thing. Like if you look at an application that is serverless, you have lambdas, you have API gateway configuration, you have lots and lots and lots of little cloud services which are basically part of the application. Like in previous ways of building applications, they would have been part of the application. And so the line ends up being really, really blurred, where the infrastructure and the application is sort of one big blurred thing. And I think that that's maybe a direction we're going. But then you also see some people who are building like a big internal Kubernetes platform, and they actually draw quite a clean line where, all right, the Kubernetes platform is the infrastructure and we're responsible for everything underneath, and the application developers are responsible for everything on top. But the line is very, very clearly drawn. And so, and that's probably a little bit more of what it's like when we're using Puppet and things like that, where the line is fairly clear in Puppet of like, we're managing the operating system here and all of the baseline stuff, and then the application goes on top. And you can draw that line pretty cleanly, as long as you do a good job of architecting your code and things like that. And so I don't know, to be honest. We're going to go in one of the two directions. Either infrastructure and applications are going to merge such that you can't see the boundaries anymore, or they're going to separate and have quite clean boundaries. And I see both people being successful. So I'm really not clear on which is going to win out.
Yeah, probably both, I guess. No, there will be both kind of any kind of infrastructures in the future. At least now, I guess. No, with more or less balances in the solutions. You mentioned Puppet. Do you think what can be the role of Puppet in current and today's infrastructures? I mean, it was done almost 20 years ago for problems which probably are no more the problems we have now in terms of computing.
Yeah, I mean, I think that the role of Puppet is going to remain what it has been for a long time. It's the best way to configure an operating system. And if you have an operating system, that's, in my opinion, that's the way you should be setting it up. And so there's still things that require operating systems, and all of those things, in my opinion, should be using Puppet to configure them. So for us, like, we do a lot of containerized stuff. Those containers mostly don't have operating systems. But if you're running something that is a little bit more traditional, it runs, it's running on a VM. I don't really see its role as changing all that much. It's always been the best way to do that, and I think it will continue to be the best way to do that. And there will continue to be applications for a long time that work that way. I think that the part of Puppet that will change and that we need to be better at when we're building Puppet infrastructures is that Puppet was very far ahead originally. Like when we were doing things entirely manually, Puppet was so far ahead that it was crazy to see how much better it was. Now that people's expectations have changed, I think that what Puppet can provide, especially if you're in an environment where you have both, where you have some stuff that needs to be on an operating system, it needs to be on a VM, you have some stuff that is more cloudy, more like as a service. Puppet should be able to take that old stuff and make it feel as a service. You should be able to make a request to something that puts some data in Hiera that goes and configures a traditional database on demand through an API. Like, it allows you to take that old infrastructure and make it feel like the cloud infrastructure. And now that people's expectations are set at that level, I think that that's what we need to be doing next. I think that we need to be using Puppet to allow our on-prem stuff to be interacted with in the same way as our cloud stuff, to be provided as a service, to be standardized and abstracted, and the stuff that we've always been doing, but now people actually expect it because they're used to it with cloud. And so I think that we just have to, the bar is continuing to be raised with what your Puppet config should be able to do.
Yeah, indeed. If you had to start your IT career now, what kind of things you would try to study or to investigate? What would be your path?
Oh, that's a good question. I had a weird studying journey. I studied a very general degree. So I did like accounting and databases and a bunch of sort of random stuff. I am very interested in the mathematics behind generative AI and LLMs and stuff. It's all been around for a very long time, and long enough that I could have studied it when I actually did study, but I didn't because I'm bad at maths, and I'm still bad at maths. So being a little bit better at maths and having a little bit of a better grasp of the like all of the matrix operations that go on under the hood, I would quite like to know that, and I may still go and study that, to be honest. I'm finding it really interesting being able to use things like vector embeddings, which are used very commonly with LLMs, being able to use those for doing things like clustering sets of, in our case, like risks based on meaning, so that we can detect common risks and common problems. That's all super interesting to me, and I think I would, and I'm getting there. Like I'm learning it more and more, and so is the whole industry. But being able to go and build some of that stuff from scratch would be dead interesting, I think.
Yeah, and what about the complexities of the IT world? I mean, if we think about that, when we started several years ago, I guess it was quite easier. All the stuff was easier. What is now a commodity at the times was the matter of things that you had to work on, operating systems or networking. And with AI, this is going to go to the next level, probably, with more and more things which work under the hood, and maybe we don't really know what is happening. How do you think we will handle this raising complexity, which at the same time looks to be at least user-facing more and more simple? We try to make things simple for the users, but behind there is a lot of more complexity.
I agree that things are getting more complex, but I think probably there's a caveat to that, which is that while things are getting more complex, the knowledge that we are building around that complexity is much more useful and much more transferable in the age of cloud and standardization and things like that. Like I remember the knowledge that you would need to know coming into work at a bank, for example, was all about how they had built their particular internal giant database cluster thing that was entirely hand rolled by a bunch of super smart people internally. And it was complex, but that complexity was information that once you quit and went to another job, you might as well just throw away because nobody was doing anything the same. Where AWS is complex and there's a hell of a lot of services, but once you understand them, you don't have to throw that away every time there's a new problem. It is, it's complex, but it's standardized. And I think the standardization is really, really helpful. It makes things a lot easier to just come in and recognize what's going on, and it reduces the amount of sort of tribal knowledge that you have to soak up when you join a new team, when you look at a new project. I mean, I'm sure that you're an absolute pro at soaking up that tribal knowledge, like going to different customers all the time and seeing, all right, how have you done this? How have you done this? But while things are getting more complex, I think it's helpful that the number of tools that we're using is starting to reduce. Well, maybe the number of tools is not actually reducing, but it seems like the ways to achieve things are
the ways and the patterns.
Yeah, like there's less total building blocks, or at least maybe less ways that you can arrange the building blocks. Certainly it's good that, you go from one company that's using RDS to another company that's using RDS, and it's the same thing, where previously you go to one company that's using Postgres and another one that's using Postgres, and it's almost completely different in terms of how it's set up, how it's configured, how it works, how you interact with it. So yeah, I think the standardization is helping. Certainly from Overmind's perspective, that's the only reason Overmind is possible, is because there's a big set of APIs that we can hit to go and find this information. Whereas if that big set of APIs didn't exist, we could never do the discovery. It's not possible. So there's probably more stuff now, but in the same note, it's more discoverable. It's a bit more standardized because it's more well documented.
Yeah, I guess the maturity of the IT also has grown a lot. So probably some standards have emerged and are stable enough to be consistent. And I guess also open source has played a big role in this field. Your personal opinion about the open source matters which are emerging in these times, where look at the Terraform. By the way, do you support Tofu or as well, or is just, I guess, is the same, at least mostly?
It hasn't diverged much yet, so we support both. Certainly, like the plan format, that's what we rely on, hasn't diverged yet. But once it does diverge, we'll continue to support both. It'll just mean that we have to actually do something different to handle it.
And your opinion on what is happening in this world?
It's interesting. I think that open source has always been super powerful, and it always will be. Like the things that standardize standardize the way we do things will always be open source. We will always agree on standardizing to something open source. I think if we look at open telemetry is probably the best example recently, where you had Datadog and New Relic and AppDynamics that all had their own proprietary instrumentation format. Open telemetry has won that battle and was always going to, because it was open source. It's absolutely the logical thing to do. And then these companies who previously had a massive moat because, you know, in order to switch from Datadog to New Relic, you had to rip out all the Datadog stuff and put in all the New Relic stuff. It's not true anymore. They both support open telemetry. You can just switch. You can switch live if you want. So I think that open source is always going to win in these sorts of situations. But I can also see where some companies are coming from. Like running a company myself, I need to think about making a profitable, scalable business out of it. And so I can see how some companies are afraid of what they end up building being turned into a product by another company who has not contributed back, and then that company making all the money instead of you when you're the one that built it. And I think anyone can agree that it's not right. It's not right that someone should just be able to repackage the work that you've done and make vastly more money than you.
In some ways, an abusing of the open source freedom. And I definitely agree on this.
And I think the licenses are getting better. Like we're slowly working out how to write a license in such a way that it prevents that sort of abuse without. And I think that is I think it's abuse. It feels wrong to me. It doesn't feel right. But I think that the licenses are getting better at preventing that sort of thing without restricting the freedoms that make open source good. The more and more modern licenses are more and more specific to say, like, Amazon, please don't turn this into a paid service, but everybody else can do whatever you want. And you know, while it's not truly free in like a free software sense, for most intents and purposes, it is, you know, for the average user it is. And I think that we're getting better and better at finding the middle ground.
Yeah, I guess so. And I definitely think that most of the software we're using now wouldn't be used at least as much as it is now if it weren't open source.
Absolutely.
So that has made the difference. So I always ask to these in these episodes some people I should invite. Some people particularly smart or interesting to talk with. Do you have any name to suggest?
Oh, that's a very interesting question. I would love to see David Woods from the Ohio State University, or anyone else that has been doing research in that the field. So David Woods has done a whole bunch of research around like human factors and the factors that influence the way people think and the way that people understand when they're dealing with incidents, like technology incidents. David Woods ran a group called, I can't remember, but they produced a report called the Stella report, which I recommend everyone read. It was meant to be a 1-day workshop in New York, but then they got snowed in and it turned into a 3-day workshop because everyone was trapped. Nobody could leave the hotel. And they did this amazing work on studying a bunch of outages and what went wrong, and then understanding how did people come to understand what went wrong, what were they thinking, what did they know at the time, what tools did they use. It's really interesting. And there are a bunch of other researchers as well in that space, which I think are doing really excellent work. And I have found myself really enjoying their research to understand what in order to make systems more reliable, what do we actually need to do? Like, how do humans think in these scenarios? So I wish I could introduce you, but I don't know them. I just think that they're great.
Well, we'll try, I guess.
We'll try. I'll see what I can do.
Ratcliffe mentioned you. Oh, that's interesting. And actually, it's always interesting to know about new people and new things happening around. And this world is so big, no? So many brilliant minds around, and so many interesting tools and everything. Which do you ever feel the FOMO of new tools to work with or new technologies to explore, but for maybe lack of time or any other reasons?
I do a little bit. I mean, I'm in a very privileged position as a founder that part of my job is making sure that I'm up to date with all of the newest tools. And so I spend a reasonable amount of weekend time doing that. There'll be some new blog that I've read or a research paper around a new technique for, improving accuracy on some LLM thing. So I'll just do that on the weekend and give it a try. And then present my results to the team on Monday, and then we'll implement it. So I think our best turnaround was from publication of the research paper to us using it in production was, I think, 2 weeks, because the research paper came out, I tried it, and it worked. So we rolled it out to production. It was a specific technique for reducing hallucinations. But so I'm lucky that I get to do that sometimes, but by the same token, there's plenty of stuff that I'd love to jump into that I don't get the opportunity to do. But I would definitely encourage people, if they haven't, if they're looking to get into, like, the AI stuff is what I've been focusing on a lot recently, but it's very easy to get into once, like, not using something like LangChain or like the complicated ways of doing it, but getting into like very simple, seeing what an LLM can produce. There's lots of ways that you can use it in your day-to-day work, where it is actually helpful. So yeah, I think I definitely recommend people try to. I have the opportunity to do it a reasonable amount, but it does often have to be on weekends, to be honest.
I guess in these times you don't need to recommend to use because everybody is using.
Well, yeah, everybody is trying it. Yeah, and it's easy. It's easy to have a go, and it is exciting.
Do you have any tool maybe to recommend, both on the, let's say, desktop world and maybe also in the infrastructure? Something that you particularly enjoy?
Oh, in terms of tools that make my life easier, VS Code and dev containers are probably the most useful thing that makes my life easier. Do you use dev containers, Alessandro?
No, but of course we studio code. Yes.
So the way it works is you have VS Code, and if you were, say, you've got like you work in a company that uses Puppet and it uses Ansible and it uses, you write some Java or some Go, you then have to have on your computer Puppet and Ansible and Java and Go, and maybe there's different versions. You might have a Puppet 3 implementation that you're keeping alive and a Puppet 7 or something that is much more modern, and it means you have to have these different versions of the things installed, and it sucks, and maintaining them sucks, and having different people with different versions installed means that there's discrepancies, and it worked on my computer. I hate that, and dev containers fixes that. So basically you define a container which the VS Code will build for you. So it'll build a container to install all of your dependencies, Puppet or Java or Go or whatever it is, your whole development environment. And then it installs the VS Code server into that container, but the VS Code front end runs on your laptop. So it's still a fully fledged app on your laptop, but it's communicating with this container, which means that if you're on Windows, you can install all your Linux stuff. It runs in a Linux container. Everything works nicely. You get exactly the right version of all of your dependencies, and then you commit that config to the repository so that everyone else on your team can just clone the repository and then click reopen in container, and they get all of the dependencies that they need immediately with no work at all. I don't think there is many people that is not applicable to, and I think everyone should be using it. It is so much easier.
Because for Puppet stuff, I typically use remote SSH to work directly on a Puppet server directory. Just for my own personal interest, the use case for Puppet development, okay, you said you have the full stack locally, but then you have to test it. And what do? You test it on the container itself, where you have... so I don't know. I feel like more comfortable than just having at least a setup where you have a Puppet server and you work directly on the Puppet server testing files via remote SSH and do work.
I mean, and in fairness, that because if you need a test environment, but that test environment needs to be a fully fledged operating system, usually depending on what parts you're automating, then you need a VM and they need to connect to it. And in that case, something like remote SSH, like the VS, especially the VS Code remote SSH plugin, because then it actually installs the VS Code server on the targeted thing so that everything feels like it's running locally, but actually you get like the native experience. In that instance, I probably would recommend the SSH, doing it over SSH. But if you're doing something where you don't have to actually modify an operating system, like you don't need the whole stack, dev containers are very, very, very good for it. But I do agree that you couldn't use it for every use case.
Okay. Any technology on the infrastructure side or operations side, which actually you think is quite promising?
I have been this is maybe a little bit more towards the application side, but we were in the beginning writing REST APIs for Overmind. And I think that, to be honest, this is something that infrastructure people are getting more and more familiar with, is writing your own APIs to make, to allow people to self-serve, create a database server, hit an API, and we go and give you a database server, and then the infrastructure team, manages the Puppet and the provisioning and all that sort of stuff. But more and more we're building APIs. So I've been looking into better technology for building APIs. I didn't like building REST APIs because I found the open API syntax to be sort of confusing for how you define what the API needs to look like. And then also it didn't generate good code, like good libraries for you in things like Go and TypeScript. The typing wasn't great, and it annoyed me. So I use a tool called Connect. It's basically the most ungoogleable thing in the world, but it's at buff.build. No, it's not. Yes, it is. Hold on, let me quickly double check. It's at buff.build. So Buff is the company, Connect is the protocol. Of course, none of those, you have to Google them all in one massive thing to get to the right website, but Buff is the company. I'm pretty sure Connect is the protocol. It uses protobufs rather than JSON as the format that it talks in, and it allows you to do things like streaming APIs really easily. So you can send one message and get many messages back. Like if you wanted to self-serve, for example, people getting logs from somewhere, you could write an API in the Connect protocol where they tell you which instance they want the logs for, and then you send one line at a time back in like a big stream. It handles all that for you. It does a really good job of generating libraries. So you don't have to say, okay, developers, here's how you call the API. You can say, okay, developers, here is the JavaScript library, just use this, or here is the Go library, or Python, or whatever. So if you're exposing things to developers, it's way better to make it as easy as possible. And by doing this, you get really high quality libraries that they can just call without having to actually construct the JSON themselves. And you get lots of nice things like streaming RPCs and like strong typing and stuff like that. I have been loving it. We use it for absolutely everything now.
Okay, cool. Good to know. So IT runs fast. We have seen our world changing, and skill keeps on changing. Let's play the future seekers. How do you think we will have will be infrastructures in 10 years or 20 years? What kind
That's a good
of
question.
computing? No, it's not a good question because it's who knows. But anyway, your ideas on this.
I think that defining things in code is the right way to do it. And I mean, as you said, Puppet, nearly 20 years. So we've been doing things in code for a long time. I don't think we're going to stop doing that. I think that things are going to still be in code. I think that our abstractions will get better. Things will probably get easier to use. But to be honest, I don't see a massive change in the way that we run things, especially with like AI and stuff like that. I don't think that AI is going to be running stuff for us, making decisions. It's incredibly inefficient. It doesn't always make the same decision. Running infrastructure is something that you need to be pretty confident about. You need to know that it's going to do what you said it would do.
Well,
and so I think that
sorry,
things are going to stay code.
I mean, I probably think the same, but at the same time, I guess since the AI world is running so fast, who knows, in 10 years, what it will be able to do.
Maybe. I mean, maybe they'll be able to help us more. And I suspect we'll write less of the code. I expect that AI will write, like AI already helps me to write a reasonable amount of my code. But I do think that building like the craft of doing a good job of your architecture, doing a good job of defining the abstractions, being able to work between teams, having like well understood contracts between the infrastructure team and the application teams and who's responsible for what and things like that, that is not going to go away. And we need to be good at doing those things. The technologies that we use to achieve that is going to change, but the companies that do a good job will be the companies that could do a good job of that stuff, of providing clear contracts. And by contracts, I mean like human understanding, usually, not like a written down thing. Maybe it's written down, maybe it's not, but understanding of who's responsible for what, that we provide this as a service and it's standardized and things like that. The companies that do well are always going to be good at that. The tools they use will change, but I think that is going to remain one of the most important things that we can get good at.
Okay. Is there a question I haven't asked you which you would like to reply to? Anything you would like to talk about?
I noticed that you asked Nigel, in 100 years, what kind of computer will you be using?
What will
I want to know I've got an answer to that. I want to know your answer to that.
I don't know, but I guess that I will still have a QWERTY keyboard somewhere under the hands. I don't know in which field. I don't think we will. We will probably talk with computers as we are doing now, but I still think that one of the interfaces will be a keyboard. And it will be still a QWERTY keyboard because who is going to change that? I don't know.
My guess is the exact opposite. I always come up with, ideas that I think are good ideas when I'm not at my keyboard. Almost invariably, I'm walking down the street or doing something and I'm like, oh, I'd like to, I wonder whether this would work. Oh, I need to remember to Google that when I get back to my desk. I would like to be able to ask my computer these things in a way that wasn't embarrassing on the street. I can ask like Gemini on my phone, but it's embarrassing, talks it back to you in a weird voice on speaker. I don't like doing it. I never liked speaking to my watch when I had a smartwatch. I think we're going to develop a way that isn't embarrassing to speak to and isn't like a weird, socially strange. And I look forward to that. I look forward to be able to ask my computer to look something up for me and have it ready for me when I get back, without looking like a weirdo when I'm doing it.
Yeah. But I guess I do agree that probably in public, we will not be talking too much to our systems. We will probably not have big things in front of our eyes. The only acceptable thing is an eyeglass, which sooner or later probably we will have.
I mean, maybe if you can fit it all into a set of glasses, yeah. Maybe we'll change and it'll be more acceptable. I mean, it's already reasonably acceptable to have it on the phone, out loud conversation on the street, but I can't do it. I can't do it at all. I can't do it. I can't talk to a watch. I can't do it.
Who knows? We will see, I guess, sooner or later, hopefully. Good. So I guess I don't have too many. I mean, we can talk about things for long. But by the way, will you be in FOSDEM Configuration Management Camp this year? Will we meet there?
Good question. Probably. Almost definitely, but I'm not 100% sure yet. I love config management camp, so I will almost certainly be there. Yeah, I haven't booked anything yet, though.
Okay, you have time, I guess. Wonderful, Dylan. Thanks for your time, and see you somewhere soon.
Thanks, Alessandro. It's great to chat.
As usual. Bye.
Bye.
Abnormal DevOps Iterations.